Alright, my little math friends, we are on our last part of chapter 12, 12.4, and we're going to be using experimental probability to make some predictions. So we calculated experimental probability the last couple of lessons. Now we're going to use it to make predictions. The experimental probability is already going to be calculated for us, which is nice. So now we're going to make a prediction. So let's take a look at our first problem. Danae found that the experimental probability of her making a bullseye when throwing darts is 2 out of 10. Okay, so that's her probability. I'm going to put lines around that because we'll need that number. That's the probability she has, the chance at throwing a dart into the bullseye down here, right there. Okay, so what she wants to know, or what we're going to find out, if she throws the dart 75 times, about how many times would she be expected to make the bullseye? Okay, so that's what we're trying to find out. How many times would she be expected to make the bullseye? Okay, what we're going to do with this is we're just simply going to multiply. Okay, we're going to multiply the experimental probability by 75 times to figure out what that would be. Alright, there's two ways about it that you can do. I'll show you the first way here. We can take 2 over 10 and multiply that by 75 times. We got to make that 75 over 1. Okay, we do the math on that. You multiply straight across. You get 150 over 10. You can simplify that down to say 15 times. Okay, so that would be our answer. She would be expected to hit the bullseye 15 times if she threw the dart 75 times total. Alright, we could also do the same thing if you don't like to multiply fractions, you could also use percents. So 2 out of 10 would also be the same as 20%. Okay, so you could use a decimal number if you'd like. You could take, that comes out to 0.20, so you can take 0.20 times 75, and you would get the same exact answer. It would also equal 15 times. Okay, so you could choose which type of math you want to do, fractions or decimals, to get the same answer. Alright, so that's how we go about solving that type of problem. Let's take a look at a couple more here, and we'll see what we have. Here's our next one. A car rental company sells accident insurance to 24% of its customers. Okay, so I'm going to put some brackets around that because I'm going to need that. Out of 550 customers, about how many customers are predicted to purchase insurance? Okay, so I underlined my question. I got my two pieces of information in brackets that I need to solve the problem. So we're going to do the same thing. We are going to multiply. Alright, so we're going to take 24%, change that into a decimal by moving our decimal point 2 places. That gives us 0.24. Multiply that by 550 because that's how many customers there are, and that will tell us how many people are predicted to purchase insurance, and you're going to get 120, well, actually not 120, excuse me, you're going to get 132 customers. 132. Alright, so the answer to that question, 132 customers are predicted to buy that type of insurance. Okay, simple, just a one-step problem to figure that out. Let's take a look at my last example I have for you guys before we end this video. Here we have an online poll for a movie site, shows its polling results for a new movie. If a newspaper surveys 150 people leaving the movie, how many people can it predict will like the movie based on the online poll? Okay, so let's go with this question first. How many people can it predict will like the movie based on the online poll? Okay, and we have 150 people. that are going to be surveyed. Here's our online poll. 72% of the people liked the movie, 28% of the people did not like the movie. Okay, so we're going to do our same step. We're going to multiply. Alright, so we're looking for people that like the movie, so that's this number right here. We're going to take 72%. You can make that into a decimal by moving the decimal point 2 places to the left. So that gets you 0.72. And then we're going to multiply that by the 150 people, because that's how many people are going to be surveyed. So when we do the math on that, it's going to tell us how many people like the movie. 0.72 times 150 gets us 108 people. Okay, so that's how many people liked the movie out of 150. The next question. Is the movie site's claim accurate if the newspaper has 104 people say they like the movie? Okay, so is it accurate if the newspaper says 104 people like the movie? Well, it is accurate because there's 108 people predicted to like the movie, and they're saying 104 people liked it, so yes, that would be just fine if they say that. And if we want to get all mathy on this and like put this into math language, we can say yes, because 104 is less than 108 people. Okay, this is how many people like the movie. If they say 104 people like the movie, then they would be fine to say that. Alright, because it's still within that range. And there is your last lesson on chapter 12, and I'll see you guys next time in class, and we'll work on some more of this together. Don't forget that try this question so you can get some points for that, and we'll work some more of these problems out next time. Thanks for watching the lesson.